Alright, in this video we are going to look specifically at the power reducing identities and how to use them in proof-like settings. So here we can see we've got the power reducing identities. So these identities are for the major three trig functions. So we've got the sine, the cosine, and the tangent. And so as you can see, each of these power reducing, so notice these are all squared. Well, when you look at what they turn into, one thing that you should notice is that first, they are all cosine, but second, notice they're all the cosine of a double angle. So that right there should be your hint that you can use the power reducing identity to reduce something down, and then from that, you could use double angle identities to continue down further should you need, or should the result be there. Okay. Now a lot of that has to do with what your example is asking. So if you look at this first one, the example here says to use the power reducing identity to rewrite the expression as directed. And so here we're saying you're going to rewrite, so we want you to rewrite the sine cubed of x in terms of only first powers of sine and cosine. So what that means is that we want to make sure that we only have first powers, meaning sine to the first or cosine to the first. Okay. So I have sine cubed here. So the first thing that I need to do is I need to say, okay, if I'm going to take my sine cubed of x, well, I need to be able to reduce that down into something I can use. I don't have an identity for sine cubed, so I do have one for sine squared. So I'm going to go ahead and take this and turn it into the sine of x times the sine squared of x. Why? Because algebra says that when you are multiplying, you add the powers. So a first power of sine times the second power, add them together, 1 plus 2 is 3. So we're basically taking the ideas that you learned in algebra and we're applying them to trig, but in a way that we're kind of working backwards. Now here, notice I have a first power of sine, but I have a sine squared, and I have a trig identity for that. So I can rewrite this yet again to say that I have the sine of x, and I'm going to multiply this by my sine squared. So I'm going to replace it here with this power identity. So this is going to become 1 minus the cosine of 2x all over 2. Okay. Now with this, I need to rewrite this nicely, and so I would multiply into my numerator here, and so this would become the sine of x minus the sine of x cosine of 2x all over 2. And what you should notice is that I have first powers of both sine and cosine. I'm not asking to reduce the double angles, so I can go ahead and leave it. The only thing I wanted to satisfy was this back end first powers of sine and cosine. I have done that, so I have simplified as far as I need to go. Alright, let's look at another example here that's just a little bit more involved. So here I've got cosine cubed sine squared, and I want to use first powers of cosine only. So I'm going to look at cosine cubed and sine squared the same way that I viewed the sine cubed. And so here I've got cosine cubed of x times the sine squared of x. So the first thing I'm going to do is I'm going to work with my cosine cubed, and I'm going to go ahead and reduce that. So here this can become the cosine of x, the cosine squared of x, and then I still have sine squared of x. Now I have a cosine squared, so we have the cosine squared identity. So as a reminder, let me go ahead and do it like this. So here we're going to use this cosine squared identity, which says I'm going to now add instead of subtract. So here this is going to become my cosine of x. And I'm going to multiply it by 1 plus the cosine of 2x all over 2. And then I'm going to multiply this by the sine squared of x. Okay, so we are almost there. I have sine squared of x here, and so I need to change that. So this is going to still be the cosine of x. I have 1 plus cosine squared of x all over 2. And this is going to be multiplied by, now I'm going to use my sine. So this is going to be 1 minus the cosine of 2x all over 2. Notice I don't have any more powers, and so I'm going to go ahead and start using my algebraic knowledge to make this look kind of a little bit nicer. So the first thing I'm going to do is I'm going to focus on these two fractions. So here this is going to be the cosine of x still. And I'm going to multiply this by combining these fractions. So I'm going to have 1 plus the cosine of 2x times 1 minus the cosine of 2x. And because this is multiplication, this means the whole thing is now over 4. So I have to FOIL, so this becomes the cosine of x times 1 times 1 gives you 1. And then I'm going to have minus cosine of 2x plus cosine of 2x. And then I'm going to have minus the cosine squared of 2x. And this whole thing is over 4. So one of the things that you can notice is that my cosine of 2x here is going to cancel. So this is going to leave us with the cosine of x times 1 minus the cosine squared of 2x, and the whole thing is over 4. Now, if you look at this, one of the things that you can notice is that I can manipulate my cosine squared of x. Okay? So if you look, cosine squared, if you remember, gave me 1 plus the cosine of 2x. So here, my cosine squared is going to become 1 plus my cosine, and because this was already a 2x, this means it becomes 4x. This whole thing is over 2, and this piece here is still over 4. So we need to be able to reduce this. And so first and foremost, you would have to combine your fractions across the top. And so here, this is a 2 on the bottom, and this right here is a 1. And so you have to turn this into 2 over 2. So what's going to happen here is we're going to have the cosine of x times, this is going to be 2 minus 1 plus the cosine of 4x. This is over 2. This whole thing is over 4. Well, your fraction rules say that you're going to keep the fraction on the top and use the reciprocal of the bottom. So this will become 1 over 4. So what we have here is we're going to have the cosine of x times 2 minus 1 is 1 plus the cosine of 4x, and this part is over 8. The only other thing that's left for us to do is to multiply this in. So here what we actually will end up with is the cosine of x minus the cosine of x, the cosine of 4x, all over 8. Okay. So to make that a little clearer, what we actually have, I'm going to turn my paper sideways here, is we started with the cosine cubed of x, sine squared of x, and we have reduced that down to say the cosine of x minus the cosine of x, the cosine of 4x, all over 8. And this was the result that we were looking for. So in a way, if you notice, this is, in a sense, very similar to verifying an identity, if our identity had to be with cosine cubed and sine squared. Okay? So essentially, that is what you're doing when you are working with power reducing ideas. You are changing it around so that you no longer have the power and instead you have a power of 1. So if you have any questions, please let me know. If you feel like you need to see a couple additional examples besides these two I showed you, let me know that too. I'll be happy to work those out. Otherwise, I hope you enjoyed yourself as much as I did, and I look forward to seeing you next time.